This is the second, pardon me, video in the series of using camtrapR. I'm just carrying on directly from the first video, which was about getting set up in camtrapR and getting everything organised so that you can start extracting data. So you see we have our DAT, we have our renamed file path and folder, and we still have this plot open. Important to keep that open for now. And what we're going to do next is we're going to now create a record table, and this is the real key part. So essentially what we're doing here is we're reading from our renamed images. We're going to get the species ID from metadata. There's a few exclusions, so there's things that aren't proper species that we're going to not use now, because that's going to have implications if we try to do species richness maps and we're counting things like people or pull up and set down as species. We're setting minimum delta time to 15 minutes. I'm going to run this now because it'll take a few minutes and I'll keep talking. I think everything is good there. So minimum delta time 15. So what we're doing here is we're filtering all of the data from the camera traps so that if we have a photo or photos of a particular species at this one camera, which are within 15 minutes of each other, we're going to tell R to ignore them. So what we want to do is have a count or a tally of the independent detections of each species. So if you think about it in terms of a lace monitor may turn up at a camera trap that's got chicken, and it might be there for 45 minutes, and we could get 250 photos of that lace monitor. But really, with what we're doing here now, there may be other situations where you do want to know exactly how many pictures you had of that lace monitor, but for all intents and purposes, that's one detection event. Even though the animal's there for 45 minutes or so and there's lots of photos, it's just one detection event. And that's what we're trying to say here, that the animal has to disappear from the station for 15 minutes at least before we count it as another detection. So I hope that makes sense. And we're just saying here what the delta time is compared to. So we're saying it's the last 15 minutes since the last record of that species. We're saying here how the species metadata tags are set up, and this talks back to Digicam and the way that we tag them. The time zone, it's pretty straightforward. We've got write CSV as true here. So in some of your worked materials for the class that might say false, but it's actually good to have it written as true, and I'll show you why in a second. And we've just said where we want the species record table to be dumped to. In this case, I've just put it back into the working directory. Let's have a look at the working directory. And there you go, we can see the record table, and it tells us it's a 15-minute delta time, and this is the date that we set it up. Let's just have a look at that to see what it has created. This table is what everything else that we're going to do pretty much is based on, that and the camera trap table with the lats and longs that we loaded as DAT at the beginning. So you can see here it's arranged by station and species in alphabetical order, and we've got here sort of the file names and some of the metadata info, which we're probably not really going to rely on too much going forwards, and the date and time as it comes off the GPS and then split, and also this information on delta time in seconds, minutes, hours and days. So you'll notice for each species delta time is 0 at first. That's because delta time is about how long it is since the previous record, and you can see here, and obviously it makes sense for the first one there is no delta time, but then the second detection of a brush turkey at this site, for example, was 2.2 days later. Dingo, there was only one detection event, so there's no delta time info, and so on, all the way through all of our stations and all of the species. So we don't have, I know we do have in here something that we probably don't want, but we'll get back to that in a second. Actually, I'm going to close that because we're going to want to edit it. I won't bother saving that because I didn't make any changes apart from just expanding some other columns, so that's non-consequential to us. So having done that, what we can do is just have a look at the number of rows, 88. So that's basically telling me that for the set of camera data that I have, there are 88 independent detections of different species. We can also have a look at the structure in here. And we can see just some information about the types of data, etc. So you could create tables with this data in the usual way, and I'll show you that in a second. Species RT. Okay, I'm just going to turn this off at the moment because it's not something you need to worry about at this point. And we can just look at that. We've already had a look at it in Windows Explorer, but it'd be good practice if you're not doing that to also just to use this head again, just look at the first 6 rows of data and check that it looks okay. So we can actually generate a few bits of summary data here if we wish, and what I need to do is change this so that it matches this one, SPPRT. Oops. Count by species, so let's have a look at what happens if I run this, and then we have a look at it. So you see here that we can, just using some sort of typical R syntax, we can create a data frame or a table with the various species. And at this point what I'd do is I would look through these species, and this is where we'd check, are there any that aren't like valid species. And there's one that slipped through, unknown murid species. We probably want to get rid of that. What else do we have? Antechinus species. Well, we leave that in there, I would say, because there are multiple antechinuses in there. Right, so moving forwards from this point, there are 2 ways to deal with this unknown species. We could go back to record table and just add it into here. But if you're working with heaps and heaps of camera trap images, like you guys will be, it's quite a lengthy process to do that. So another way you could approach it would be to go back to your record table. Just take a moment for this to load. Expand the species. You could sort and filter by species, and you could just go through and manually remove them. So I'm going to do it here for, you can see unknown murid. There was a few of them. I'm just going to delete them. Now I want to save this with a slightly different name so I can differentiate it. So I'm just going to call it mod, and I'll remember that that's the new one. Back into R. I'll just expand that window a little. So what I want to do now, using any of these other commands, is to load this back in. So rather than species RT being our record table, I'm going to rename it. I might, just to make it a little bit easier for you guys to follow, I might name that as mod. And if I have a look in my working directory just to make sure I got the name right, I simply have to add mod to the end. Oops, what's happened here? So it's telling me there's no such file or directory, so there's something wrong with the name that I've used here. So what is it? Record table underscore 15 delta T 2019, the date. Alright, that's worked, and so now that's gone in here. So everywhere that we would otherwise have used this, where we're telling it what the record table is, we now want to tell it use this one instead. And I would suggest that in order to avoid any mistakes, because you can imagine that as we go through you could easily put the wrong one in, is I'd actually get rid of that. So let's use this rm command again. So the CSV file of the original record table is still in our Windows directory, but it's no longer in our global environment, so we can't accidentally call it. So if I go back into here, I can run this table again. Oops, let's keep going with that. And unknown mirrored is still in there. What has happened? Species. Let me just try that again. This is curious. Have I made a mistake? The mistake I've made is that I didn't capitalize. Now if we go back and have a look, you can see there's no unknown mirrored in there. What I'm going to do with this next line of code is to change these headings so they actually make a bit more sense. And you can see now that they've changed to being sensible headings. And I want to save this as a CSV file, and I use this bit of code. So the function is write CSV. The object is count by species, which is what I called the data frame. And then in inverted commas is the name that I want to give the CSV file, and it makes sense to me to give it the same name because it was an intuitive name, and you can see that it's just popped into my environment. We can of course look at it from here without formatting, but just to see that it's what we think it is, or we could go into Windows Explorer and open it up this way to check. Just give it a second. So you know, this is quite a nice little bit of summary data. That would be a good way to lead into your results section in your written reports. Just a simple overview of how many detections there were of each species. I'll point out here that we're using Antechinus species because potentially there's 3 different kinds of Antechinus that live in the study area. I was able to positively identify one of those pictures, but the others couldn't positively ID what species they belong to. So possibly what we might have done is renamed Subtropicus as species just so that they're all just Antechinus species. But I figured, seeing as how I could identify it, I've left it in. But you might choose to do something different. I won't save it because all I've done is to expand the column. And I'll get rid of this. Right, so we can actually do a few things here. I'm going to have to change these as I go. So I'm just going to do something just to show you an error. So you can see what's happened here is because I've forgotten to update this one, it's telling me that it's not found. So it's saying object species RT not found. The objects are all up here. Yep, it's not here, but that's what it should be called. So this, I guess, just illustrates to you ways that you might interact with those error messages. When that red text comes up, just take a deep breath. Normally it makes a lot of sense. So what we've just done here is we've done up a table of the species by the station. So now we have a count for the number of detections of each species at each station. Again, a really cool little table to have that you might use. And I'm going to write that to a CSV, and there you go, it's just popped into there. So the next thing we want to do is to run a report. I'm going to, again, I'll get an error message when I run this, because the object species RT wasn't found. So you can see that we're referring to this record table throughout, which highlights why it was so important that I got rid of that original record table name. Because if that object still occurred there, R would just go through and process it and produce an output, and I'd have no real inkling that I was making a table based on the wrong record table. So if, as you're going through doing this, you're getting a table which includes those unknown species, or the non-species, that's a sign for you that you need to go back and sort things out. So I'll run this now. So don't forget that you may well have to change some of these column names if they don't match up with your camera trap table. Whenever we modify the species record table and reload it the way that I did up here, we also need to include this line of code, which you don't need otherwise, which is telling it the format of the date in the record table. Otherwise it will, I'll just get rid of that, and I'll run it again, and you can see what I'm talking about. So you're seeing it's saying it can't read the date format. That's because I've opened the record table, modified it, and even though I've saved it as a CSV file again, it has trouble recognizing it. So I'll just pop that back in. No matter how much mucking around you do, it just won't read it. That said, there can be all sorts of other troubles with date format, but they shouldn't happen here when you're just working with this record table that R's created. So there's some really useful stats here. Again, you might use these in your methods or your results. So the total number of stations that you surveyed, and the number that were operational. We have the number of camera trap nights that were set up and active, 126. So this is simply the number of operational stations multiplied by the number of nights that they were set, and also the total trapping period. So you can see that this would fit really neatly into your methods section. This might be more in your results. Again, your preliminary results when you're introducing your results would be to say, we collected images from 10 stations over 126 126 camera trap nights during the study period, or something like that. But there's actually also a lot more info in this report. If we have a look at the structure of the report, there's 5 data frames that make up the report. One are the survey dates, another is species by station, events by species, and events by station. And you can have a look at them just by using this familiar sort of R syntax. Let's have a look at the first one. I'm actually going to add here report 1 so we can have a look at what it looks like. And that's, as you see, there's the station and there's the number of species that were recorded at it. And we can do it for all the different sections. I'm going to go report 2. So I want to look at the data frame. Let's look at the second data frame, which is species by station. I just want to have a look at that. Oh, sorry, that's the one that we just did. Silly me. Let's have a look at events by species. And see what's in there. There we have, for each species, there's the number of detection events and the number of species at which it occurred. So all of this data might be nice summary data, but it also can be used for your further analyses. So don't just stop at this point. What we're doing here really is summarising the data, and it can be useful to show those summaries in your report in the results section, but you should also be thinking about how to plot it, or how to do some more testing further on. And we can just carry on doing this with each of these five data frames within each. So I'll stop that there and we'll start again with a new video.